In this video, we will be running the computations using the terminal. Now, overall, running any type of calculations uses the same commands, not explicitly the same, but you have to do some changes. For example, if you're running a DSCF, direct SCF, you would have to write DSCF, but basically the same extension file. That also applies when you use RICC2 or basically ESCF for TDDFT. When you're getting the excitation for using the TDDFT. Before we proceed with the calculations, let's check the control file, which is the input file. So this is what the input file would probably look like. It depends on how you're actually just using everything. So if you're using the GUI, it should probably look something like this, depending on, of course, your basis sets and everything else. But for the one that we prepared, it will most likely look something like this. But if we're also using the terminal, but if you've used the terminal to prepare the input file, there will be a little bit of changes. For example, the title, subtitle, the atoms themselves. It doesn't really specify atoms like this. No, it just gives you atoms, basis set and auxiliary basis set, and that's about it. But basically everything else is mostly the same. So we have the input file, we have the basis set, auxiliary basis sets, and the molecular orbitals, and of course the coordinate. We need all of these files. For the molecular orbitals, for example, if you don't want to use these molecular orbitals, because these are provided based on these basis sets, which is the def2 SVP, for example, you want to change the basis sets, and this is something that's really nice in TurboMole. We can change the basis sets and use external basis sets easily. We don't have to go into a hassle to do so. The only thing you would need to change is just this command. And just like I mentioned in the video, you would need to remove this command. And if you do that, you can change the basis set to whatever you want, and then provide do the DSCF calculations, and of course get the initial molecular orbitals for RICC2 or something else to do the calculations. Now, to proceed with the calculations, there are a couple of things you need to keep in mind. You need to set up your environment properly so that TurboMole reads the commands, and so that you're able to do the computations. That's the first thing. And the second thing is that whether you're doing parallel computations or not. Now, on this computer, I'm not really doing any parallel computations using the terminal. Using the GUI, it's quite easy. You can just change the number of CPUs, put in the maximum CPUs, you can do that, and just run your computations. But when it comes to the terminal, you need to set to do extra commands so that you can actually run that. I'm doing that on the Digital Alliance of Canada, on Compute Canada, or Compute Canada on Cedar and Graham. So you can do that on the cluster because the Linux environment, I believe, is much easier than the Mac OS environment. So I'm doing all of that because I'm also running all of my computations over there. Because RICC2, I'm using like a lot of CPUs and a lot of threads so that I'm able to get to my final output files, because it takes time. Of course, it depends on the electronic structure itself. So let's make sure here we have the environment set up. So instead of just keep writing some of the commands and I want to know where I am exactly or where to go, I just put everything is just on the bash file. So on the bash file, I have it here. Also on Compute Canada, I have the bash file. Basically, everything's there. And the parallel environment is set up over there as well, so that I don't have to do anything. So you just need, if you write source for the bash file, it will run the bash, and that's about it. And I already know from this, I know where TurboMole is. So I can, but before I go to TurboMole, but this TurboMole extension is needed to run the computations. Before I do that, I need to go where I'm going to run the computations, which is this folder, the job SP3. So let's do that and head there, which is what we prepared a couple of minutes ago. So we're here now, and we can see that we have basically everything. So let's just run the extension and see what we can do herein. So we want to get to the extension, and this is the extension on an Apple, on a Mac OS. There's the one I have herein. It depends on where you install TurboMole, of course. And I want to run a DSCF. So you just write DSCF, something like this, and then DSCF. And I want my input file to be just DSCF. .out. And it started running, so you can see it's actually running, and everything seems to be okay. And once it's done and everything is good, we have the DSCF ended normally. Now, just to make sure about one thing, so we have the DSCF out file here, and we can see that it terminated normally. the molecular orbitals, we had an initial guess, Huckel, initial guess, but right now what we have is based on the DSCF, so it actually runs and gets us the molecular orbitals and swap them with the Huckel guess with the converged ones. So that's for the DFCF. Let's say we want to do RICC2. Of course, you can change the name of the input file, whatever you want, but you need this command like RICC2 to be exactly like this, based on what TurboMole is set up already. You can do RICC2, and of course, you can do the computations based on what you want. It started running, so it seems to be running. That's good, and that's how you do the computations. Of course, that's for RICC2 and DSCF. You need the DSCF first, and then RICC2. You can do TDDFT, which is basically easy. The same input file that we prepared in the previous video, and then just instead of RICC2, you remove the RI, or you can do RIDFT, or you can just remove the RI and then just proceed with selecting the functional. It is recommended to use the M4 grid size for TDDFT when you're doing vertical excitations, and of course excitations in general, like you're doing two-photon absorption or something like that. You use the M4, and instead of doing RICC2 and DSCF, the first thing you do is DSCF, and the second thing you do is ESCF for the excitation for TDDFT. And we can see that it's running here. The files, they're just changing, and that's how you do RICC2. This is for one photon absorption. Running the commands for one photon to photon, everything is basically the same. The commands, they're the same, doesn't really change. Nothing happens. So that's the videos for running TurboMole using the terminal. Now for the next one, it will be two-photon absorption, preparing an input file for two-photon absorption. And this cannot be done using the GUI. We would have to use the terminal. It is a must. This is something we will look for. Yeah, that's it. Thanks.